All right, so every unit has one of these packets. You can download it or you can get it off, or do it on, I should say, Google Docs. So it's your choice. If you have a printer and you want to download it and do it that way, by all means. Google Docs is another way. For submission for these, Google Docs will be the preferred way. But if you have trouble with that, we may be able to do like snapshot pictures. But Google Docs increases the grading time. Decreases the grading time and increases the ability for me to get them back to you. So each one has first off the state standards. That's what the state requires, and then it has a list of standards-based objectives. This is basically everything that this packet covers in an objective standpoint. So after you do a section, you may want to go through here and then see which one of these you can do. Today is the first lesson, and that deals with scientific notation. So the second page is the scientific notation notes. In science, we have two types of measurements. We have quantitative, where we sit there and maybe take a ruler and measure the length of something, and that requires a unit. Or we have qualitative measurements, like for example, you know that anything above a 93% is an A. 90 and to 93 would be an A minus. Those are qualitative. Or large eggs. The eggs have to be within this size range to be considered large. Color is also a qualitative measurement. Hot would be a qualitative measurement, but 100 degrees Fahrenheit would be a quantitative measurement. Notice you do need that unit at the end. Otherwise, if I just say, oh, it's 100, most people would say, oh, well, the temperature is 100 degrees, but I could have been talking about, it's 100 miles from here to Cincinnati. So just keep that in mind, that you need that unit if you're going to quantify something. So scientific notation is a way for scientists to basically notate large, very, very large, or very, very small numbers. So if we have something like the size of, well, the coronavirus, that's going to be a very, very small number. So if we were to measure that in millimeters or centimeters or meters, we're going to need a lot of zeros because it's going to be a very, very small decimal. If something were very large, for example, the distance from here to the sun, that's quite large, or the distance from here to a different galaxy, even much larger, or the number of ants that are on the planet, or the number of atoms in your eyeball. Those numbers are very, very large, so we'd have a lot of zeros on the other side of the decimal place to put that digit way out here. The scientists said, well, we don't need those zeros really. We can use scientific notation and then multiply everything by a factor of 10 or a factor of 1/10. And that's what it does. So let's take a look here. Here we have 6,200,000. So if I take this decimal right here and I go whoop, 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 I just move that 1, 2, 3, 4, 5, 6 times. So if I multiply 6.2 by 10 6 times, that will be the same number. And I've reduced the amount that I have to write. So this 6 tells you how many times you're going to multiply this number by 10. This number is called the coefficient. That coefficient always has to be between 1 and, well, 9.9. Otherwise, you would just put add another 1 to the exponent if you were above 9.9. If it's below 1, then you should be using 1/10, or multiplying it by 1 over 10 6 times. And that's denoted by having the negative exponent. So, again, 1, 2, 3, 4, 5, 6. We move the decimal this time over here 6 places. If we didn't move it, if we only moved it 5, then we'd have 0.6. We can't have that. And if we moved it more, then we would have 62. We can't have that either. So keep that in mind. Let's do one by hand. 540. We know there's a decimal there, 1, 2. So we moved it 2 places, 5, 0.4 times 10 to the second. Here we have 0.00000540. So we're going to move this 1, 2, 3, 4, 5. And we have 5.4 times 10 to the negative fifth. Now this 0 right here, that's written for a reason, so we're going to have to put that here as well. Any 0 that is at the end of a number past the decimal point means that this is accurate to that place value. So 5.40. These zeros, they don't need to be written even though they're on this side of the decimal because they're not important. This is saying that after that 4, there was a 0 there. This is saying that after the 4, well, we don't really know what was there. We have no idea. Now to go the opposite way from a number in scientific notation back to normal notation, we just do the same thing. We have 6, and then we would move the decimal 1, 2, and then add zeros until we get up to 7. So 1, 2, 3, 4, 5, 6, 7. It's customary in our country to put commas there. So 6.93 times 10 to the 7th is the same as 69,300,000. If it's a negative, we do the opposite. So this time we move this 1 this way, and that is going to be 0.12. Now the cool thing is our calculators can do this. If you've not purchased one of these yet, make sure you do get the TI-30X2S. We have been trying to get other departments to make sure that they, have you buy these as well, so that you only have to buy one calculator. I know some of you have the graphing calculators. They will work, but you'll have to work a little bit different. If I have time near the end of this video, I'll discuss how to do that. So, if you follow along with these instructions, you can do this very easily by just reading. Versus doing that, I'm going to just go ahead and show you versus reading you every step. So currently, our calculator is in flow. Flow means it's in normal notation. 9,000 is 9,000. 560 is 560. If I switch this over to Psi by hitting the second button and then the DRG button right next to it, and then hit enter, then the 560 becomes scientific, 5.6 times 10 to the second. 9,000 becomes 9 times 10 to the third. 0.00058 becomes 5.8 times 10 to the negative fourth. Your calculator can also go the opposite way. If I wanted to type in 5.8 times 10 to the negative fourth, we hit second and then this EE button right here. That's the only way to do it. Don't use the 10x button. That's different. That's the anti-log button. We want this EE button right here. So we're going to hit that, and then a little E pops up. That means times 10. And I believe it's to the negative fourth, so we'll hit negative fourth after. And the calculator will do that. Boom. 5.8 times 10 to the negative fourth. Let's try a different one. Well, let's go back to normal notation. Second, DRG. Go to flow, and look. It switches it to normal notation. Again, that's second and the DRG button. Flow is for normal. Psi is for scientific. So if we're in normal notation and we have, well, let's just do one. 8.7 times 10 to the 7th. 8.7. Again, that E button right here, we need to hit the second function of it. Times 10 to the 7th. Boom. It changes it right to normal notation for us, and then we can sit there and write that out. Now, obviously, we could have done this in our head. 1, 2, 3, 4, 5, 6, 7. Boom, boom. Same numbers. Or 7.6 times 10 to the negative 7th. Boom. 0.1, 2, 3, 4, 5, 6, 7. Right? Or we could have went from here, 1, 2, 3, 4, 5, 6, 7. Either way works. Now if we want to do these down here, if we want to do this with math, all we're going to do is type in these numbers. 6.4 93 times 10 to the 7th plus 8.7 times 10 to the 7th. We click it. There's the normal notation. 156300000, and second ERG, go over to psi, boom. 1.563 times 10 to the 8th. 1, 2, 3, 4, 5, 6, 7, 8. So I told you that I would show you if I had time, and I think I do. If you have one of these big bad boys, you can still do this stuff, except for your normal and scientific is under mode button. So if we switch over to psi and we quit, if I type in 9,000, boom. If we go over to mode and then go back to normal, and then we quit, we type in 9,000, boom. So if I have 9, and notice where the EE button is here, it's the same place, second EE, 3, boom, 9,000. 7.8 times 10, second EE to the negative 6th, boom, 7.8 times E times 10 to the negative 6th. If we go to mode, go to psi, wait, that's a normal, that should have been. Maybe these won't do it as well. Maybe that number's a little bit too big. Let's try third. Yeah, you may have trouble if you're using one of these. I know it does work with the TI-30X2S. 30X2S. 7.8 times 10 to the negative 4th. Maybe it just doesn't do it with the negatives. Let's try again. 7.8 times 10 to the negative 2nd. Okay, so yeah, it won't go as far. And this is again why we use scientific notation, because there's only so much that that line can handle. I think this line could handle a little bit more than the 4 here. Let's try this. And just for good measure, well, I wasn't normal. So yeah, if anything, if it wants to change it to scientific notation, even in normal it will. So if you got one of these, you may want to upgrade and get one of these. They're about $10 usually. They may go up to as high as 15. But yeah, I don't know what they're on Amazon. So you have the rest of the, you have about 20 minutes to go down through this and do it. Otherwise, what you don't finish there is for homework. Thank you.